Okay, looks like probably should use quotient rule on this one. So derivative of the top times the bottom left alone minus the derivative of the bottom, which would be bring the power down, lower the power by 1, and chain rule times the derivative of the top left alone all over the denominator squared. So, I mean, technically that is the answer. As an FRQ, if it just says find the derivative, you could literally stop right there, and if you don't have any mistakes, you should get full credit. But of course, most of the time this is going to be multiple choice, and we got to practice simplifying this. So over here I noticed that I have 2 of these guys squared, and then over here I have a negative times a negative, which becomes a positive. 2 times 2x would be 4x, times 6x would be 24x squared, and there's this guy, another one of these. Now right here it's kind of tempting to square this out. I mean, it gets a little messy, but it was tempting. But what I noticed was is that it matches up with the denominator, so we can probably get something to cancel here. So if you consider this term has a 1 minus 3x squared and this term has a 1 minus 3x squared, you should consider factoring that out front as a GCF. And over here, this would leave 2 times 1 more of these. I'll just distribute that 2 now. Couldn't distribute the 2 before because of order of operations. You have to deal with the exponent first, but since I'm factoring 1 out, now it's to the first. Okay, and if I factor this out, then what's left over here is a 24x squared. And then the purpose of factoring that guy out that I have highlighted there is now I can easily see that this guy is going to cancel out one of those. And in our numerator, looks like we get 18x squared plus 2 over 1 minus 3x squared all cubed.